Hello everyone, my name is Jalal. I'm a researcher of artificial intelligence at Sweden University, and today I'm so excited to present our recent work that is about CardioNet Plus. CardioNet Plus is a federated learning-based multimodal approach for early detection and personalized care in cardiac disease. This paper is published in Frontiers in Psychology, and I try to make a summary for this paper in only not more than 10 minutes. So cardiac disease are the leading cause of death worldwide, and they suffer from we have different systems, different approach for this disease, but the point is that they suffer from different limitations. For instance, low accuracy, privacy concern, and poor generalization are three main limitations that they have. Low accuracy, there are so many reasons for low accuracy, but one reason is that they are dependent on single data source. Privacy also is so important in especially in healthcare, and also poor generalization. So here, to improve the results, we try to learn the approach, the model from multiple data types, while trying to also protect patient privacy. So our approach was CardioNet Plus, that is a federated learning framework that integrates 4 types of data: ECG, cardiac image, patient history, and nutrition data. And by using a federated learning, we also try to keep privacy. So the first step was pre-processing. We have 4 types of data. It means that we have 4 types of data pre-processing. So the first one, for cardiac image, we use 2 types of pre-processing. The first one was median filtering, that tries to remove noise while keep important A's. And also we use mask RCNN for segmentation. That the goal of using mask RCNN was isolate key heart structures like the left ventricle from MRI or CT scan, and actually that part was ROI for the image. For ECG signals, we use 2 types of pre-processing. The first one was bandpass filtering, and the second one was ICA. Bandpass filtering was the goal of bandpass filtering was to retain only the frequencies associated with the heart activity. That is typically a number between 0.5 and 50 hertz. And also we use ICA. ICA is a famous signal processing technique, and here we used ICA to separate the ECG from artifacts like muscle or eye movement. And after that, we had a clean ECG signal for the next step. The next step is feature extraction. For patient record, that is called sometimes electronic health record, we use only 1 type of pre-processing, that is min-max scaling or normalization. We had some features like age, like blood pressure, like cholesterol. So we try to transfer all numerical features into a standard range. And after that, we have nutrition data. For nutrition data, we have some features like daily calorie intake, ratio of saturated fat to total fat, and also protein to carb ratio. So in this case, we use K-means clustering. K-means clustering is an unsupervised approach for clustering the data. So here we group patients into clusters based on their dietary intake, like for instance, high protein or high carb diets. And K-means assign each patient to a dietary cluster by minimizing the distance between patient intake profile and the cluster center. After pre-processing step, we extract features. We have different types of data. So we have different types of feature extraction. At least here, for image, we use ResNet 50. For ECG, we use fast Fourier transform that captures dominant frequency from ECG. Also, we extracted statistical features from patient records like mean and variance. And also, we extracted nutrition ratio for diet patterns. And after that, so we have 4 types of features. And after that, we fuse the mix all features by using an attention-based mechanism. So in this figure, you can see the general approach that we use. We have 4 different types of data. The first one was image. The second one is ECG, patient record, and nutrition data. After that, here in the second step, you can see the pre-processing step. That, for instance, they are different for different types of inputs. For instance, you can see for image, we use median filtering and segmentation. For ECG, we use bandpass filtering and ICA. For patient record, we use min-max scaling. And for nutrition data, we use k-means clustering. After data pre-processing, we use feature extraction. That for the first one, we use ResNet 50. For the ECG, we use Fourier transform FFT. For patient data, we use the statistical features, and for nutrition, we use some other features that I already mentioned. And after that, we use attention-based feature fusion for mixed features. And these two parts are the main step. These 3 parts actually are the main step for this paper: pre-processing step, feature extraction, and after that, feature fusion. And after fusion the features, we can use a deep network for actually the classification purpose. But something that is important here is that we use federated learning. So centralized learning is the traditional approach that all data is collected and stored in a central server, and model training is performed there. But in federated learning, we have a decentralized learning approach. It means that the model is trained locally on some devices that is called node, and only model updates and not data. And only model updates are sent to the central center. You can see the results in the paper, but in summary, Federated CardioNet Plus achieved 90% accuracy, while, for instance, for centralized approach, we could achieve a result of 94. So we can say that our approach could provide higher accuracy, higher privacy, and also better generalization. And in this presentation, I tried to give you an insight, a summary of our paper that we called it CardioNet Plus, and it was a powerful step towards privacy preserving intelligent healthcare. And it not only predicts cardiac disease with high accuracy, but enables tailored lifestyle guidance for patients. And thank you for your attention. If you have any question, you can send me an email.